All right, in concept F, we're going to be using table R to name and draw organic acids and esters. Organic acids have what we call a carboxyl group, which is the combination of a carbonyl and a hydroxyl group. So we have a double bonded oxygen, and on the same carbon we have a hydroxyl group, an OH. So this, as you can see, because of the placement, has to always be at the end of a chain. So for the organic acids, which is one of our electrolytes of organic compounds, the carboxyl group again is at the end of a compound. So we say that the carboxyl groups are always on primary carbons, so we're not going to need to show any numbers to show the location of that carboxyl group. One thing to note is that the shorter the attached hydrocarbon to that carboxyl group, the stronger the acid. And to go back to the electrolyte point, remember, normally molecular compounds are not electrolytes. However, organic acids, because they're going to be able to put hydrogen ions into solution when they ionize, are one electrolyte out of organic compounds. So when we go to name these, we're going to be dropping the E at the end of our hydrocarbon chain and replacing it with oic and then adding the word acid as the second word in the name. And again, because those carboxyl groups are on the primary carbons, there's no need for a number. So when we look at the example on the screen, if we were to go to name this, we want to focus on the carbon chain, which we have two. So that's going to be my prefix F. Our two carbons, including the carbon that is attached to the oxygens. And then we're going to replace the E in ethane with the fact that we have this carboxyl group. So this is where we put oic acid, and because it's again placed on the ends of chains or on the primary carbons, there's no need for any numbers. So ethanoic acid. Here we have pentanoic acid, so you want to focus on the prefix that's going to show us our carbon chain, which gives us 5. Then, because it is an organic acid, we're going to add that carboxyl group and then filling in hydrogens into the rest. And you can see no additional hydrogens go on the carbon that has the oxygens and the hydroxyl OH group. All right, now esters I think are probably the trickiest one on table R for most students to name. These have two oxygens that are in the middle of a chain. This is formed when a carboxyl group is surrounded by two alkyl groups. So instead of the carboxyl group being on the end of the chain, it's right in the middle, surrounded by two different carbon chains. Usually we're going to see when we get into organic reactions, these are produced by the dehydration of an acid and an alcohol. Usually esters are great because they have a nice odor to them, so they're used in a lot of different products for that reason. All right, so when we go to name these, there's two parts because of our two different chains of carbons. The parent name of our ester is going to come from the hydrocarbon chain that contains both oxygens. That's our base or our parent chain. That's the one that we're going to write as an alkane and then replace the E at the end of the name with OH. Now, the first name that comes into our esters is the hydrocarbon chain that's only attached to the single bonded oxygen. We're just going to name this as we would any other branch, so we're going to use terms like methyl, ethyl, propyl, and so on. So here we have an ester, and I can notice that because of the two oxygens located in the middle of the chain. You're going to see that here I have on the outside, this is the one that's bonded singly to the oxygen. This is our branch. That's going to be my methyl group. And then I'm going to locate the parent chain, which is the chain that's attached to both oxygens, which are those three carbons. That's going to be the name of the group attached to that, again, carbon with the double bond oxygen and the other oxygen, and then I change my ending to OH, so methylpropanoate. Here I have propylbutanoate. You're going to see first I'm going to start with my parent chain, so these are my 4 carbons that contain the oxygens both attached. So I'm going to fill in the double bonded oxygen and then my oxygen on the other side of the carbon. And then I'm going to fill in my branch, which is my propyl group, and then I fill in the corresponding hydrogens, and that's it. So again, you got to be a little careful with esters just because of the two different prefixes that are being used and making sure you put those carbons in the correct spot.